Today we're going to introduce memory. So first, I'd like for you to write down everything you have to do after AP Psychology today. So when you're finished with this class, what do you have to do today? Pause the video. What you just did was an exercise in what we call prospective memory. And this is remembering our ability to remember actions that we have to perform at a later time. So you thinking about all the things that you have to do at some point in the future, we're referring to your prospective memory. So I think oftentimes we think about memory as pertaining to the past and us remembering things that have happened in the past, but it also pertains to us having to remember things that are going to happen in the future. So human memory is an information processing system, and it works it works by performing three different tasks. It encodes, it stores, and it retrieves information. So we're going to focus today mostly on the process of encoding. Memory generally is any system, whether it's a human model or an animal model or your computer or your phone. It encodes means it takes information and puts it into or translates it into a language that can be stored. Think about when you have to store a file on your computer and then retrieve it later on. That's essentially how the brain is working relative to memory, although with some exceptions that we'll get to in a second. But your memory is always working with your perceptual system. We learned about sensation and perception. We learned that we have sensory receptors at all of our sensory registers, and we are taking in information at all of those sensory receptors. And that information is being converted into patterns that can be stored and retrieved later. Think about what a powerful relationship there is between smell and memory, right? Like a particular smell can act as a cue or a trigger for memories, as can something like a song also act as a cue for memory. So memory is working with our perceptual system, and it's taking meaningless information from our environment, like my voice that you're listening to right now, and hopefully turning it into meaningful patterns that we can store and use later. Now, we've learned about learning strategies this year, so you know that you need to engage in what we call effortful processing. If you want to take this meaningless information, like the stuff you learn in school, and convert it into stuff that you can remember or that you've learned and can retrieve later on when you need it. A lot of us tend to think that our memory works like that of a video recorder or like, the camera on our phone. The reality is our memory is very much interpretive. It's very fallible. It is very prone to distortion, and we'll spend a portion of this unit talking about what we call the sins of memory and just how susceptible our memory is to distortion. So our memory is good at storing information on which our attention is focused. If your attention is not focused on something, you're never going to remember it. Any of us who have read the same page in our book 10 times or the same page in our notes 10 times and not processed anything, you know what lack of attention does to memory. It's good at storing stuff that we're interested in. If we're interested in something, we're likely paying attention, right? Making connections. It's really good at remembering stuff that arouses us emotionally. The involvement of the amygdala, the connection between the amygdala and the hippocampus, means that in times when we are emotionally aroused, when we're in the midst of that fight or flight response, or just any time we're really emotionally aroused, we're likely to remember that moment. Information that fits with our previous experiences, and think about that process of elaboration that we talked about very, very early in the school year. We said it's so crucial that you take in new information and you connect it to what you already know, or that you create concrete examples. So our memory is good at storing things that fits with stuff that we've experienced in the past. And it's really good at remembering things that we rehearse or that we effortfully process. Elaborate rehearsal, we're going to learn, being the best type of rehearsal for remembering. So look at the importance of attention relative to learning. Again, if your attention is not focused on a task, the process of encoding is going to be much more difficult, and the process of storage as well. So again, just an overview, the three tasks that we're learning about are encoding, storage, and retrieval, and we're talking today about the process of encoding. So encoding happens mostly without any of our conscious awareness. And it involves our brain taking in information from our environment and converting it into a usable form. Now, this involves selecting one stimulus from many, which involves our attention being assigned to that particular stimulus, to that person's voice, or to that particular sound, or to that particular object that's sitting right in front of you. If you're going to remember it, you need to select it from the environment, identify it, and then label it in order to make it meaningful enough that you're going to remember it later on. So our sensory memory is the information that comes in and is stored for a very, very brief period of time at our sensory receptors. And we learned about all of our sensory receptors back in the sensation and perception unit. So you know that those sensory receptors are at our eyes, our nose, our ears, etc. Working memory reads the sensory information and decides what it's going to admit to our attention, or decides what we're going to be paying attention to. Think of your working memory as anything you're thinking of at any given time is in your working memory. We take very, very little note of the details in our everyday lives. We're going to talk more about that in a second. Meaning that most of our memories are pretty vague and most details are very sparse. And what happens is when we go to recall an event, our memory of the event is actually pretty foggy and pretty lacking detail. So what do? We fill in the gaps that exist without even realize that we're filling in those gaps. And we end up creating a memory as opposed to accurately retrieving a memory of something that really happened. And that's what I was talking about, memory being very interpretive in nature. All right, and think about this. Anytime you meet a new person, right? I'm sure we've all been in the situation where we meet a new person, they tell us their name, and not 2 seconds later, you've already forgotten the person's name. It's because you haven't assigned your attention to it. There's no such thing as being bad with names. If I meet someone whose name is Jen, I automatically have to think to myself, oh, like Jen, like as in Jennifer, I have a sister named Jen. Okay, so you've got to make those connections if you want to be able to remember. In order to make connections, you have to assign your attention to the task. So tell me which is the real penny. Pause the video. Check out these pennies. If you said A, you are correct. Now, I'll give it to you that a lot of people don't use a whole lot of coins anymore, not handling tons of cash. But we've certainly seen enough pennies that we should know which one is the real penny. Every year I ask this, and very, very few people get it correct. It's an example of how little attention we pay to everyday details. Here's another one. So you can pause it again and figure out what the correct Apple logo is. If you said B, you are correct. Now, say that we don't know the penny, or we don't know the right Apple logo. We refer to this as an encoding failure, or a failure to encode, a failure of the information in our environment to be put into a format that can be stored in our memory so we can retrieve it later on. It can occur from lack of attention, like we've been talking about, but also other factors like trauma or substance abuse. But whenever we fail to encode something, or we fail to convert that information into that which can be stored, we refer to it as an encoding failure.